Have you ever wondered why some AI agents seem to work like magic, just effortlessly delivering incredible results?
Yeah, while others, well, they consistently fall flat. They struggle sometimes even to maintain a basic conversation.
Exactly. And after, sifting through a stack of fascinating analyses and real-world case studies, one critical factor just jumps out. It's the absolute game changer.
Yeah,
Context engineering.
context engineering. Yeah.
Right. And this isn't just some technical skill, it's really, I think, the foundational art that determines the quality, the consistency,
Uh-huh.
and ultimately the intelligence of any AI system you build.
That's a great way to put it, the art, yeah.
Now, let's really unpack this a bit because, look, many people understandably confuse context engineering with prompt engineering. It's an easy mistake.
It is. They sound similar.
Right. Prompt engineering, in essence, is like crafting that single perfect command for an AI, a finely tuned instruction for one specific task.
With telling it exactly what to write.
Yeah, but context engineering is something, well, much broader, much deeper. It's the art of building entire systems capable of dynamically providing exactly the right, relevant, and necessary information to your AI agent.
Precisely when it needs it.
Exactly. Think of it this way. Prompt engineering is like cramming for an exam the week before. You're meticulously preparing answers for questions you expect.
Okay, I see where you're going.
Whereas context engineering, that's like showing up to the exam with a perfectly organized, living reference binder, a comprehensive knowledge base you can consult, update, and leverage on the fly whenever needed.
That's a fantastic analogy. And what's truly fascinating here, I think, is the sheer transformation it enables. Without proper context, an AI can really only answer these isolated, factual questions,
Ah.
like, what is the capital of France?
Right. Very reactive.
Exactly. It's a reactive tool limited by its immediate input. But with, well-designed context architecture, an AI just transcends that limitation. It becomes a true assistant. Well, it's capable of remembering past interactions, accessing vast external knowledge, and then acting intelligently on that information. It's not just an upgrade, it's like a fundamental shift.
So it goes from just looking things up to actually planning.
Planning, anticipating, executing, it mirrors how really intelligent human assistants operate. I mean, imagine asking an AI, okay, based on my previous trips to Europe and my strong interest in contemporary art, recommend a 3-day itinerary for Paris.
Okay.
That includes lesser-known galleries, and then book a table at a traditional, highly rated bistro nearby for Friday evening.
Wow. Okay. That's multi-step.
Exactly. That level of proactive, personalized, multi-step action, that's only possible with robust context engineering.
So here's where it gets really interesting. To address this core challenge, we've identified 6 essential context engineering lessons. We think these can genuinely transform your AI agents. These aren't just, abstract concepts, they are practical principles. They'll elevate your AI agents from simple Q&A tools into truly intelligent assistants, capable of remembering, learning, performing complex actions.
Yeah, because most AI agents today that don't use proper context engineering, well, frankly,
It's like talking to someone with severe short-term memory loss.
that's exactly it. They
Yeah.
can't build on previous interactions. They can't access
Yeah.
relevant info or maintain consistency. It's frustrating.
Yeah, and we're going to show you exactly how to fix that, how to unlock their full potential.
Let's do it.
So let's start with the absolute fundamentals. At its core, context engineering is, well, the art and science of feeding an AI agent the precise information it needs.
Yeah, at the exact moment it needs it.
Right, so it can complete tasks effectively, reliably. This really is the solution to that digital amnesia problem we talked about.
Absolutely. It allows your agent to become a reliable, intelligent assistant that actually evolves with every interaction.
Okay, so how do we achieve that? Where do we start?
Well, I think it's vital to understand the sequential information processing flow every AI agent follows.
Yeah.
If you get these building blocks, you can design much more robust, much more efficient systems.
Makes sense. What are the blocks?
So we see 6 fundamental components of context you can provide. First, obviously, the user input. That's the dynamic request from the user.
Okay.
Then the system prompt. This is essentially the fixed brain defining the AI's role, its personality, what tools it has access to.
Got it. The core instructions.
Exactly. Next up is memory, which helps the agent retain information across interactions. Super important. Fourth is retrieve knowledge, the agent's ability to search and pull info from outside sources.
Like looking things up.
Precisely. Fifth, tool integration, enabling the AI to interact with the digital world, perform actions.
The hands and feet.
You got it. And finally, structured output, which dictates how the AI formats its response. Now, the critical insight here is you don't always need all 6 for every single interaction.
Right, you pick and choose.
But knowing their roles empowers you to optimize and create, purpose-built AI.
That's a fantastic breakdown. And leveraging these effectively brings us to what we're calling the 6 essential lessons for mastering context engineering. Our first key lesson, without a doubt, is understanding and optimizing memory.
Crucial.
Memory is what truly makes AI feel more, well, human and profoundly useful. It lets it learn, build a relationship with the user over time.
Yeah.
So when we talk about memory in AI, we can kind of categorize it into 3 main types. First, there's working memory. This is temporary, used for single executions. Think of it like the AI's scratch pad.
Like jotting down a quick note.
Exactly, like remembering, my next step is to process the result from this tool. Then there's short-term memory. This covers the conversation history within a limited context window.
Okay, so like the current chat session.
Right, allowing a single chat session to maintain a coherent context.
And that coherence is absolutely crucial, isn't it, for any meaningful conversation. When you're setting up short-term memory, you define the context window length, which is
Essentially, how many previous interactions or how much text history the AI will actually remember. And session IDs are absolutely vital here too.
MISA.
They allow your agent to have unique, separate conversations with different users. Keeps their context distinct using identifiers like, say, email addresses or phone numbers.
Gotcha. So my chat doesn't get mixed up with someone else's.
Exactly. And a critical point here, while newer models boost these increasingly massive context windows,
Yeah, they keep getting bigger.
simply stuffing them with unnecessary information can actually degrade performance, and it significantly increases costs.
Oh, interesting. More isn't always better.
Definitely not. So the art lies in balancing cost with performance, tailoring that memory length precisely to what your application actually needs.
Okay, that makes sense. And then where things get genuinely powerful, I think, is long-term memory.
Ah, yes, the persistent stuff. This is the knowledge that survives across multiple sessions. It allows your agent to become genuinely smart and informed over time. You've got several robust options for implementing this, right?
Absolutely. For instance, user graphs. These can create incredibly rich relationship maps, understanding complex connections between facts about a specific user.
So not just storing facts, but how they relate.
Precisely. Think of it like a highly personalized web of knowledge about a user or an entity. It's not just storing documents, it's understanding how different pieces of info, like past purchases, stated preferences, browsing history, how they're all connected.
Which enables really personalized responses.
Truly personalized, even predictive responses. Or, for simpler needs, methods like simple document storage in platforms like Google Docs or Notion can be surprisingly effective.
Right, sometimes simple is good.
Absolutely. But for more complex information relationships, especially with unstructured text like documents, vector databases are ideal.
Okay, vector databases. Explain those a bit.
Sure, they convert documents or text chunks into these numerical representations.
Hmm?
We call them embeddings.
Embeddings, got it.
These embeddings are crucial because they translate human language into a mathematical language AI can understand and process. By converting text into points in this sort of multidimensional space.
Like coordinates on a map?
Kind of, yeah. The AI can then calculate semantic similarity. That means it finds information that's conceptually related, not just textually identical. It allows for incredibly powerful retrieval based on meaning, not just keywords.
That sounds powerful. What else for long term?
You can also integrate with CRM systems like HubSpot or Salesforce to look up client information and tailor responses based on their profile.
So pulling directly from business systems.
Exactly. And for highly structured data, traditional SQL or NoSQL databases allow for precise queries like fetching an entire order history or specific product details.
Okay, so lots of options depending on the data type. Now, building on that idea of accessing external knowledge, particularly from structured sources like databases, there's another powerful technique. It involves giving AI agents the ability to act on that knowledge.
Ah, yes. Action.
And this is where tool calling or function calling comes in. That's our second essential lesson. So what exactly is tool calling and why is it so transformative?
Tool calling is, like we hinted before, giving your AI hands and feet in the digital world.
Right.
It allows your agent to interact with external systems, send requests, receive data back, perform actions, things far beyond just generating text.
So it breaks out of the chat bubble.
Totally. Without tools, An AI like ChatGPT can only have conversations. It's a brilliant conversationalist, don't get me wrong, but it can't do anything.
Like send an email or update a record?
Exactly. With tools, it can send emails, check a database, search the web, trigger workflows, interact with your entire digital ecosystem. This is absolutely critical for making AI agents truly productive assistants.
And this capability ties directly into our third essential lesson. Mastering our RAG. Retrieval Augmented Generation.
RA. Yes. Big topic.
Yeah. The simplest analogy I can think of is this. If someone asked you which company had the highest revenue in the world in 2023, and you didn't immediately know.
I wouldn't just make it up, hopefully.
Right. You'd look it up, probably on Google or some trusted source, before answering. Our RAG is precisely that lookup process for AI.
That's a perfect analogy. It empowers the AI to access and retrieve factual, external information before it generates a response, stops it from just making stuff up or hallucinating.
So how do you implement RA? What are the ways?
Well, you can do it in multiple ways. One common method is with a vector database, like we just discussed. You ingest your internal documents, and the agent queries that database for relevant chunks of info instead of relying solely on its sometimes outdated training data.
Prevents hallucination, gives current info.
Exactly. Or you can use web research, giving your agent multiple specialized tools like, say, Perplexity or Tavly. It can then choose the best one for a given query.
Like choosing the right search engine.
Kind of, yeah. And importantly, you can integrate with internal systems Jira for project data, Airtable for structured lists, Google Sheets for dynamic data.
So it can pull real-time business data.
Absolutely. And what's really compelling here is seeing how these work together. Imagine asking an assistant, draft a summary report on the progress of Project Phoenix for the last quarter and email it to the project manager.
Okay, a complex request.
Behind the scenes, with ARG, it might use a Jira tool to pull the project data, maybe a HubSpot tool to find the project manager's email.
Ah, combining tools.
It synthesizes the report using that retrieved data and then uses an email tool to send it off. You see how multiple RIG systems effectively work in concert.
That example perfectly illustrates the power. Pulling from different places, combining info, taking action. Okay. And to make those RG systems even more efficient, especially when dealing with large volumes of information, we need to talk about our fourth essential lesson, optimizing chunk-based retrieval.
Right, because R often involves pulling chunks of documents.
Exactly. So why does document chunking matter so much? Why can't we just feed an AI an entire book or a massive PDF?
Yeah, it's crucial because AI models, despite all the advancements, still have limited context windows. They can only process so much information at once.
Right.
You simply can't drop a 100-page PDF into an agent and expect it to process everything efficiently or, importantly, cost-effectively. Document chunking breaks those large documents into smaller, manageable pieces.
Okay, makes sense. Break it down.
These smaller pieces are then converted into those numerical representations, the embeddings we talked about.
The coordinates.
Yeah, which are placed in that multi-dimensional space.
Yeah.
This then allows for that really powerful semantic search, finding relevant chunks based on conceptual meaning, not just simple keyword matches.
But hang on, there's a fascinating challenge with chunking, isn't there? If you break documents into pieces, don't you inherently risk losing the broader context, the connection between the pieces?
That is a critical point, yes.
Oh,
How do we maintain that crucial context across chunks?
How do we fix that? Ensure the AI gets the full picture when it retrieves just individual chunks.
Well, one key technique is using metadata, essentially data about data.
Give me an example.
Okay, so for meeting transcripts, maybe you include the project name, the meeting date, the attendees, perhaps even the specific discussion section title as metadata for each chunk.
Ah, so each piece carries labels about where it came from.
Exactly. When the agent pulls those chunks, it knows precisely where they came from and what broader topic they belong to. That makes the responses much more coherent and helpful.
Okay, metadata. What else?
And then there's a more advanced but incredibly effective technique called re-ranking.
Re-ranking.
Yeah. Instead of just taking, say, the top 3 or 5 chunks from a vector search, which might be semantically similar but maybe not truly relevant to the specific question.
Okay.
You retrieve a larger set, maybe the top 20. Then you use a second, often more powerful language model to reassess their true relevance to the original query.
So a second pass with a smarter judge.
Exactly. It acts as a highly intelligent second filter, ensuring only the most pertinent information actually gets passed to the main AI generating the final answer.
That makes perfect sense. It's like quality control for context. Okay, now, while retrieving all that relevant context is powerful, it also introduces a challenge. the sheer volume of information that can be pulled.
Yeah, you can get a lot back.
And that brings us neatly to our fifth critical lesson: smart summarization techniques. Why is summarization so critical in context engineering?
It's critical for two main reasons, really. First, those context window limits we keep mentioning,
Still a factor.
still a factor, and perhaps even more importantly, cost optimization. When you pull information from memory systems or databases, you often retrieve far more context than is strictly necessary for the current query.
So you're pulling in fluff.
Pretty much. This wastes tokens, which
Mhm.
significantly increases costs, especially with large models. And it can also confuse the model with extraneous noise, ironically degrading performance sometimes.
Okay, so how do we get around that cost problem and keep the AI laser focused on what actually matters?
Well, there are a few ways. You can use techniques like controlled context retrieval. This is where you make separate targeted requests and filter for only the information that is truly relevant to the current query.
So be really specific about what you ask for.
Exactly. Feed only essential context to your main agent. But there's an even more sophisticated approach: summarization via sub-workflow.
Summarization via sub-workflow. Okay, break that down.
So instead of the main agent querying the raw tool or database directly,
Right.
it queries a specialized sub-workflow. This sub-workflow then queries the actual tool, but here's the magic. It uses a separate, often smaller, maybe cheaper language model to summarize the results before returning them to the main agent.
Ah, so a dedicated summarizer step.
Exactly. This retains all the important information while dramatically reducing the token usage sent to your primary, potentially more expensive model.
Can you give an example of the impact?
Sure. We saw a case where, without this technique, an agent might directly access a vector database, processing maybe 2,500 tokens of mostly irrelevant context to answer a simple question.
Okay, that's a lot of tokens.
But by implementing a summarization sub-workflow, it processed only, say, 400 tokens of highly relevant condensed information. The result: comparable or even superior answer quality.
With a massive cost reduction.
Up to an 84% cost reduction in that specific case. That's a huge efficiency gain for any organization using these models at scale.
That truly is a huge saving. Wow. Okay, a game changer for cost-effective AI. Finally, let's talk about our sixth essential lesson. This one's a bit different. It's about the right mindset for context engineering success.
Yes, strategy. It's not just about the tools and techniques.
Exactly. My first piece of advice here for you is to begin with the end in mind. Before you build anything, clearly define what your agent will do, what types of queries will it receive, and precisely what information does it absolutely need to perform its task.
Yes, understanding your specific use case from the outset is key. It helps you design the most efficient and robust data pipeline right from the start, which leads directly to the second point within this lesson. Design your data pipeline carefully.
How so?
You need to consider if your data is static or dynamic. How often does it update? And crucially, how do you handle changes or new information? Your automation strategy has to account for how source documents are updated or removed over time to maintain data accuracy. You can't just set it and forget it.
And that leads directly to the third point, which is critical: ensure data accuracy.
Garbage in, garbage out. Still true.
Absolutely. The entire purpose of context engineering is to give your agent access to relevant, up-to-date, accurate information. If your knowledge bases are outdated or contain errors, your agent will inevitably give wrong answers.
Amplifies the problem, really. You need predictable inputs for predictable outputs.
Exactly. And the fourth point within this strategic mindset is to optimize the context window always. Only load the most relevant information.
Control costs, prevent information overload.
And ensure the AI focuses on what's critical. Don't make the AI read your entire textbook just to answer one specific question.
Right. And that optimization includes using things like semantic search, relevance scoring, designing specific queries that retrieve only what's truly needed. And this brings us to the fifth crucial strategic insight: embrace AI specialization.
Ah, specialization. Tell me more.
Instead of trying to create one monolithic super agent that supposedly does
The
everything,
jack of all trades AI.
which usually means master of none, create specialized agents that excel at specific tasks. Think of it like an assembly line. Each component does one thing incredibly well, then passes the work to the next step.
This modular approach sounds like it offers a lot of benefits.
It really does. More consistent results, much simpler prompting for each agent, faster execution overall, and far easier troubleshooting when issues inevitably arise.
So you could have like an orchestrator agent to route incoming requests.
Yep.
A dedicated research agent just for gathering information. A content agent specifically for writing or summarizing, and maybe an action agent for sending emails or making API calls.
Exactly that kind of setup.
Hmm.
Each agent performs its specific job exceptionally well. This really scales much better than trying to build one agent that attempts to do everything and honestly often ends up doing nothing particularly well.
Yeah, I can see that. We also saw how advanced strategies like really smart context window management through careful loading and maybe progressive enhancement and robust error handling and fallbacks
Like having multiple sources or human handoffs.
further refine this approach. And always, always remember to measure success. Look at performance, cost, technical metrics to continuously improve.
And a critical point here is to avoid some common pitfalls we see. One significant trap is definitely over-engineering.
Building something way too complex.
Exactly, when a simpler solution would have worked just fine. Another is ignoring data quality. That leads to poor performance regardless of how sophisticated your AI techniques are.
Right, the accuracy point again.
And, as we've emphasized, poor context window management just stuffing it full waste tokens and degrades performance. And finally, a lack of specialization where agents try to do too many things often results in them excelling at none of them.
Okay, lots to keep in mind there. So wrapping this up, what does this all mean for you, the listener? As we've seen throughout this deep dive, context engineering is truly the secret ingredient. It's what transforms basic AI chatbots into intelligent, reliable assistants.
Yeah, it's the shift from that digital amnesia
That short-term memory loss.
to interacting with a truly intelligent assistant capable of remembering, learning, and performing complex actions that evolve over time.
It feels like real intelligence emerging.
It does. And if we connect this to the bigger picture, the ultimate goal isn't necessarily to build the most complex system possible or, the one with the absolute largest context window just because you can.
Right. What is the true goal then?
The true goal, I believe, is to build systems that consistently deliver exceptional value. And you do that by giving your AI agents exactly the context they need, precisely when they need it, in the most efficient and effective way possible.
Efficiency and effectiveness. So for you listening, the takeaway is clear and actionable. Start with simple implementations.
Definitely start simple.
Test them rigorously, see what works, what doesn't, and then gradually add sophistication as you learn what works best for your specific use cases.
Iterate.
Exactly. The principles in this deep dive memory, tools, RAG, chunking, summarization, specialization, they'll serve you exceptionally well whether you're building customer service agents, content creation systems, or complex business automation workflows.
They apply across the board.
And an automation platform, something like N8MN, for instance, is a fantastic place to start experimenting with these ideas, maybe in a low-code environment.
Great starting point.
It lets you visually build these flows.
Ultimately, this is the key takeaway, I think. Your AI agents are only as good as the context you provide them. Master context engineering, and you will genuinely master AI automation and unlock its truly transformative power.